Welcome to Sweet Life Beat Life. We hope this video helps.
You start by confirming the essentials: Python 3, 8+, CUDA-compatible GPU, and a working virtual environment. Once done, clone the Yolov7 repo and activate your venv. Make sure to pip install R requirements. TXT so dependencies match. Next, download the Yolov7, PT weights, and place them in the project root. Finally, organize a small validation folder under data/images with a few labeled images. This gives you immediate feedback and speeds iteration when you run the first detect command. You now prepare the dataset and training loop. Convert annotations to YOLO format 1, TXT per image with normalized coordinates because Yolov7 expects this layout. Then craft a data. YAML that points to train and val folders declares NC for classes and lists names. Once that file is ready, run train. Py with sensible flags, choose img size for your target resolution, set batch size according to GPU memory, and pick epochs. Use weights Yolov7. PT to transfer learn, which speeds convergence and improves accuracy. You finish by running detect. Py for inference. Pass your image or video path and tweak conf threads and IU threads to control detections. Once satisfied, export the model to ONGS or TensorRT to accelerate deployment on edge hardware. If results look off, troubleshoot methodically. Inspect label quality first, then augmentation settings, and whether your learning rate is too high or low. Also check class imbalance, reweight or oversample rare classes, because small dataset issues are the most common cause of poor performance.
Thanks for watching. Consider subscribing if we helped you.